No problem. But Cindy, before you join, for those who have tuned in before, we like to ask an icebreaker question just so our audience gets to know you better. So, Cindy, if we were to make a movie about your life, who would be the actress and what would you call it?
Oh gosh. Okay, let's see. I'd probably choose Aubrey Plaza. Feel like we have very similar personalities in that regard. And honestly, lately, the way things have been, maybe I'd name my movie title Cloudy with a Chance of Really Unhealthy Junk Food Everywhere. For folks in the chat, I live in New York City and we have not had a day of sun, really. Well, I mean, like, there's some pockets here and there, but it's been a really weird spring and quarantine has really tested the limits of my diet. So yeah, so that's what I would name it. That's awesome.
Awesome.
Yeah, sorry, go ahead.
No, go ahead. And now take it away.
Sweet. So yes, thanks, Ashley. And thank you, Jack, who is puppeteering the slides for me here. A little bit about myself. My name is Cindy. I am a site reliability engineer at Google. I've been at Google for about 7 years now, working on various SRE teams. And I'm currently on our customer reliability engineering team. And my team is basically comprised of a group of Google SREs who go and talk to Google Cloud customers to help them adopt SRE best practices and principles so they can operate more reliably in the cloud. So today I'm super excited to talk about SRE and how to bring reliability in regards to business continuity. So the first part of this presentation, I'm going to go over what is SRE, and talk about what the core problem that SRE solves, and the high-level organizational structures that facilitate the practice of SRE. And then secondly, I'm going to talk about the key principles that SREs use to keep systems appropriately reliable. And then finally, we'll talk about the key practices we use in SRE in relation to business continuity. Finally, at the end, I'm going to leave some room at the end of the session for Q&A. But if you have any questions throughout the presentation, please feel free to send them through chat, and Ashley will make sure I can get to them and address them. So awesome, let's get started. So who here has heard of SRE? You can just nod in your screens and I'll take a quick pulse check. It's awesome. So let's start by talking the core problem that SRE solves. The first and paramount responsibility of SRE is to make sure that outages are rare occurrences, that are contained and they're limited, while at the same time helping us maximize the feature velocity of Google products. So business continuity theory for traditional areas like logistics, physical infrastructure, and finance are pretty well established. You know, when you hear about a hurricane that passes through a community in the news, and then hours later, you hear that the local Waffle House is back up and operational, it's not a surprise, right? They've been doing this for a really long time. And fun fact, there's actually something called the Waffle House Index, which is a metric that FEMA uses to determine the effect of a disaster. And it's based on the reputation of the Waffle House and its good disaster preparedness practices. For folks that are familiar, Waffle House is a dining establishment. They serve their famous waffles, and they're pretty much open all the time. And they have this really good disaster preparedness reputation and practices that they use to help themselves stay open or quickly reopen after disaster, like a hurricane passes through. So if you go into an area and the Waffle House is open, but it has a limited menu, it probably means that they have trouble getting power or they have trouble sourcing supplies. But if you go into an area and the Waffle House is closed, that probably means it's bad news. And as it stands, there's hundreds of Waffle Houses that are closed now due to COVID-19, which, among a ton of other things, really helps to highlight the severity of the pandemic. And we look at businesses today who are struggling, along as well with people in general, and they're working day in and day out to resume their business continuity in this fast-paced and dynamic state of the world we're in. Everyone is struggling regardless of whether you're a brick or mortar or online store. I know it's been a struggle for some of my friends working in different companies just to get a work from home infrastructure set up for their employees. And it's not just that, right? Traditional operations generally hasn't been as sufficient as other areas in regards to business continuity. So the focus today is to look specifically at these industries operating online and see how SRE can be used to help solve some of these business continuity problems. And if you go to the next slide, Jack. Thank you. Before I get to that, I just want to talk a little bit about the origin of SRE. So Ben Traynor, the original founder of SRE at Google, had met up with Urs Holzel, who runs all of the infrastructure here at Google. About 15 years ago, they sat down and they had a chat about just like the future of Google itself. And they did some math and projected that they would need about 1 million people to hire in the next 10 years to keep up with Google's pace of operations, right? The company was growing so fast, and they realized quickly that operations had scaled linearly with the number of machines and also the complexity of what ran on those machines, like features and products and so on and so forth. And because of this combination of more machines and more complexity, they calculated that number. So obviously, this is a huge number, and it's undesirable to have this many people working in operations, as it would end up crowding the amount of space you'd have for innovation. So there was no choice except to turn this operations problem into a software engineering problem, and that's how site reliability, or SRE, was born. And Ben Traynor likes to say that SRE is what happens when you ask software engineers to do an operations function. The goal of SREs is to always automate themselves out of a job and to use engineering practices to manage both complexity and scale. And after they've automated everything, they get to work on new and interesting things, which they would automate those jobs away as well. And next slide, please. So what do SRE teams do? So in a nutshell, we write software and design systems to scale appropriately, reliably, and efficiently. And we achieve that with a combination of 3 things. We have a group of people, a set of philosophies and mindsets, and a set of engineering practices and tooling. And to have SRE, you really need all 3 of these things. But while you need all these things, keep in mind that not all SRE teams are made the same way, and they actually vary in many different ways. One way they vary is by how they're organized and implemented. This could range from having an everything SRE, whose scope of responsibility is very broad, which is a common implementation when you're starting up SRE in an organization. Or you could have SREs just for specific products and applications such as Gmail or Google Search. There are just so many ways that SRE teams are organized. The other way that, yes.
We do have a question from the crowd. The question is SRE comparable to a PCF platform?
I am not familiar with what PCF stands for.
It's
I'll jump
in
and answer in the chat if you want to continue, Cindy.
Okay, sure. Thanks, Alan. So the next thing is, the other way that SRE can differ is by their varying levels of maturity. So when you start out, it's really common to pick up a few best practices of SRE, and then later on, as you start implementing more advanced processes and practices, you can pick up even more things. So it's never like an all or nothing type of deal. You don't have to adopt the whole practice and the whole practice of SRE for your business, right? They'll come in different shapes and sizes. Even within Google, this is true. For example, Gmail has been around for a really long time, and it has its own dedicated SRE teams that are spread across globally for maximum coverage. And there are other teams at Google who only have 1 or 2 SREs that are embedded into a developer team, right? It's like I mentioned, we come in all shapes and sizes, and you don't have to have this whole holistic SRE image of it. Next slide, please. So I want to talk about this slide a bit. So you have developers who are constantly building new features, and then generally they give them to their operations folks. And the operations folks have to juggle everything that's thrown at them while being responsible from everything from scalability, reliability, and maintenance of software. In other words, you have this dynamic where developers want to go as fast as they can, And operators are looking to slow things down as much as they can to help reduce risk. This setup's not really designed for harmony. It can be pretty brittle and it doesn't scale well. So how do we balance this? Well, there are a lot of existing methodologies in place that solve these problems. DevOps, which came along the same time as SRE, focuses on breaking down the silo between developers and operations. And you have Agile development, which focuses on bridging product and development teams. But for SRE, what we want is a system. What we want is a system that takes all three of these domains: businesses, operations, and development, and help us balance development velocity with reliability to align with our business goals. So this is the problem that SRE solves. Next slide, please. And how do we actually solve this problem? Well, at its core, SRE really just has one key principle, and that's error budgets. And before I talk about error budgets, we have to talk about reliability, specifically how we measure reliability. So when we think about reliability, we think about the traits that determine whether or not our service is working for our customers, right? So for example, if you have a website that your customers need to access, we say that if it's available, it's working. Or if you have a video streaming service, if your customers get their videos at appropriate speeds, we can say the service is working. Same thing, if you have an inventory service, if quantities and prices of your items are correct, we consider that working. All of these attributes, availability, latency, and correctness, are indicators of the service's reliability. However, they share one critical piece in common, and that's that they are all quantifiably measurable. So we look on the left at this box here, and this is a traditional approach to measuring this. It's a bit simple and somewhat naive way to do this by measuring how much time things were good overall in the measurement window. It's nice and intuitive to understand for things that are continuous and binary, like a web server. Is it up or is it down? But oftentimes you'll see distributed and complex systems where you'll need fancier definitions of reliability that can also handle whether your service is going to be partially up, and then also measure the quality of the service being delivered. The basic requirement is going to be the same. You need a definition for reliability, and you need a way to measure it. In the end, though, systems are going to be complicated. So more often than not, you're going to see distributed and complex things that you're going to have to use a more sophisticated approach for. And again, before we talk about error budgets, I really need to clear some terminology. SLIs, SLOs, and SLAs. So an SLI, or service level indicator, tells you at any moment in time whether your service was operating adequately or not. Ideally, we want to match this with our user expectations of our reliability. And we take this number and we aggregate it over time to get our SLO. So it says, over this window of time, this is my target reliability and how well I'm doing against it. And then SLA is really for most relevant to businesses. This is an agreement you can make with your customers that says, if you fail to provide your agreed upon service, you have to face some sort of consequences, such as providing refunds or partial credits. To have SLOs, it's imperative that you get buy-in from all the stakeholders in your business development and operations organizations. You can't just have your SRE teams use SLOs, because your developers will just keep pushing features and you won't be able to hold each other accountable, and vice versa, right? So SLOs help bridge all three of these domains, and they give everyone this common language to discuss balancing this work. So instead of prioritizing work with like emotions in like a meeting room where everyone's just yelling over each other, trying to get their features pushed or not pushed, you now have hard quantitative data to help prove your case, right? And the next step is to actually make a reliability goal, which is, like I mentioned, a certain amount of reliability that you want to reach for a target. So you've probably heard this term 3 nines or 4 nines service. This is really about the amount of downtime we're willing to tolerate. So in this table here, we look at the reliability level in terms of time. So it says, if you set a target of 99.95% for your service, that means you only have 4.38 hours of downtime allocated a year. And that leaves you only 21.6 minutes per 30 days. Now, I don't know about you, but if I if an outage was happening right now, I would not be able to resolve it and get it working. Well, first of all, click on the alerts, find and investigate what the problem is, and probably not resolve it within 21 minutes, if I'm lucky, right? So this is why other aspects of SRE are super important that we talk about with automation and things like that. But as you can tell, it's like this is pretty difficult to achieve. Imagine if you had a 5.9 service or a 4.9 service, right? If you can go to the next slide. So the way that we talked about this with a, this is the table on the left is a very binary measurement. Like this is talking about hard outages, 100% down. Remember, we're dealing with complex and distributed systems, so you can never really assume that you'll have like 100% outage. There's more room to maneuver and nuance if you can measure brownouts and not treat them as 100% errors. So we take this and we break it down even further, and within this 21.6 minutes, how much percentage are we seeing of errors? Like 1%, then we have 36 hours available for outage time, right? You may be thinking there's a number that we're missing here, which is 100%. Next slide, please. So we basically say 100% is the wrong reliability target for basically everything. This is the key realization that our SRE founder, Ben Traynor, had come up with. And I know if you work in finance or other high availability industries, this probably seems really unintuitive. Of course, we want our money to be available all the time. Of course, we want our customers to be able to, make their trades and things like that. But there's a reason we don't recommend that. And it really all just boils down to cost, right? There's an exponential cost in terms of time, money, and effort. Depending on your business goals, this cost probably doesn't outweigh the benefits.
Hey, Cindy, we have a quick question. So
yes.
How mature are most enterprise organizations in establishing their SIs and SOs? And what part of the org does it fall to?
So in my experience, when we work with these enterprise customers, I would say people oftentimes don't have SLIs or SLOs set up. They do, however, have business metrics that may be customer focused, but don't quite follow the same formula that we use at Google. And the journey that we take with them is to get them to use the numbers that they actually collect, make decisions with it, right? So honestly, like I would say I don't see it often right off the bat, but it is something that they work towards and they get set going with us. In regards to who handles this, the main thing that you need is, first of all, you need exec support. You need your top level leadership to buy into the idea of using SLOs and use it to make your business decisions for your organization. Without that, like it's not going to trickle down to your developers. It's not going to trickle down to your operations folks. And once that happens, you basically have representatives who represent those groups get together, decide on their target reliabilities, hold each other accountable. So it is a combination of everyone. You need all stakeholders to be involved in the process. Does that help answer? If not, feel free to send a follow-up message. But going back, what's like I mentioned, like it's really costly to achieve these 9s, right? More 9s means more staffing and more hardware resources. It means you need more people to work on automation, more people to build resilient architectures and handle incident response. For example, you need folks to engineer the work that makes it possible to help you roll back quickly and safely. And not even just human resources, right? You have servers and storage and backup that you need to now create redundancy for. So that gets really costly too. So looking at this graph gives you kind of a rough idea of what costs are associated with getting each 9. So what do we do instead of 100%? This is where, oops, can you go back to the previous slide? Sorry. This is where our error budgets come in. Instead of trying to eliminate all of your risk, we want to learn how to manage it. So if you have an SLO of 99%, the inverse of that which is 1%, is going to be our error budget, or the amount of unavailability you are willing to tolerate. Once you know how much error budget you have left, you're able to choose how you're going to spend it on potentially events that could make things unreliable, like pushing new features or doing experiments. You can think of the error budget as like a household budget. Use it to spend it on groceries or other household items, and you shouldn't be afraid to use all of it, but you shouldn't use more than what you have. So now, like, you can kind of piece everything together. You see, like, this is a very powerful and objective way to measure reliability. And going back to the problem of balancing development and operations, this is how we do it. And this is how you check whether or not you're meeting your business goals. If you run out of error budget, then you need to focus your efforts on improving reliability. But if you have enough error budget, you can increase your development velocity. And now suddenly you find like all these teams who are bickering to push the releases or not, or get releases held back, are looking to balance developmental velocity with reliability. So everyone's working together. Next slide, please. So how do we decide what our target reliability should be? Will all of your users notice if they can't access one product on your website? Probably not. The idea here is to align your SLOs to your users' happiness as best as we can. So we're looking at this graph, and the SLO is the curve line here, and below your SLO, your user happiness is probably decreasing pretty quickly, right? And most users are actually pretty happy at a balanced cost of reliability. And you could make more users happy, but it's at an increasing cost, where now you're spending more money to get this higher cost, but you don't really see that much of a huge difference in user happiness. So when you're trying to come up with a target, you want to get a target that's you can kind of exceed but not by too much, right? And you want to choose an appropriate SLO depending on your users' expectations. And I know that's easier said than done, because actually creating SLOs is pretty complex. We recommend that you just try to keep things really simple, avoid absolutes, and you'll just iterate it over time so perfection can wait. And in the next slide, we talk about good change management. And what really good change management is managing risk. And the approach is just to try to make all changes in like a routine process or standard change. But the goal isn't to break anything and go really slow. In fact, it's the opposite. You actually want to go as fast as you can until you exhaust all of your error budget, and then you need to think about reliability and you need to work on it. So, get the next slide. So I talked about what SRE is and the problem we're trying to solve by balancing development velocity with reliability, while at the same time aligning to our business goals. And I talked about how we do this with quantitative measurement data for SLOs and error budgets. But how do we actually defend our error budgets and SLOs in our day-to-day? So we look at a few key areas of practice. In the next slide, oh no, what happened to all the text? Oh, there it is. So in the next slide, this is a typical life cycle of production incident, right? You have the curve line, like I mentioned, is the SLO, your target reliability, which means if you don't reach this, you're going to have unhappy users. So you want to keep your users happy by sustaining reliability. And we want to try to find a balance on the amount of reliability depending on the business goals. So the red space is the unhappy space. If you get here, your users are probably unhappy. And the blue space is happy space, right? So example, an outage begins, a data center goes down. When the data center goes down, the first phase that we look at is the time to detect. So when it goes down to when a human's alerted to help resolve the problem, this is the TTD, or time to detect. And the next phase is from when the human is alerted to when the issue is actually mitigated. We call this the TTM, or time to mitigate. One key thing I want to note here is that mitigate really is about getting back to business continuity rather than having somebody dig into logs, find a root cause, submit an error, submit a bug, submit a fix to resolve the bug, to fix the root cause, right? That's not what we want. We want the business continuity to be back up online It doesn't matter if you can't solve the underlying issue just yet. And then the other part of this is time between failures, which is the time from when the failure ends to when another one begins. So in large, complex, and constantly changing global systems, it's not a question on if an outage will occur. It's a question of how often and how impactful they are, right? The user happiness falls when the issue is ongoing and rises during periods of stability. This is why the primary goal of an incident responder is to mitigate issues as quickly as possible and to extend the period of stability between incidents. So common mitigations include diverting traffic away from a problem area, rolling back to a recent production change, or adding emergency capacity. And the real investigation into the root cause and the implementation on a more permanent fix, like I mentioned, you wait until operations is healthy again. And after all this is done, we send out external communications once we understand the scope of the problem well enough to communicate about it. So in the next slide, we talk about postmortem. So after the emergency has been mitigated, your focus should really be on preventing the problem from happening again, making sure you really figured out and understood the primary causes and are planning to work to improve the reliability of your service accordingly. This means it's not only planning work that will prevent the recurrence of the issue you just saw, but also work to address any issues you might uncover as you start digging into these root causes, so that you can limit the impact of this type of failure from happening in the future, and also make it easier to recover quickly next time you detect the issue. And finally, a really critical thing, if you go to the next slide, Jeff. Finally, the critical thing with postmortems is blamelessness. Everyone makes mistakes, and humans are never the cause of incidents, even though we kind of jump to that conclusion when we think about that, right? But that's not the problem. The problem is that your systems allow these mistakes to happen. For example, maybe you give access to everyone to make critical changes, even if they don't need to, and then they don't need to get the proper approvals before making a change, which could cause accidental outages. Remember, we're treating operations as a software engineering problem. So when things go wrong, we look for flaws in the system that allowed the things to go wrong, and we look for ways to automate and improve it to help avoid these human errors from occurring again. And really, if you want to learn everything you can from an incident with a postmortem, you won't be able to get to the bottom of things if people are scared to tell you, like, oh yeah, I accidentally clicked this, accidentally did that, and brought this down, right? You need to have a culture of blamelessness so people aren't afraid to speak up, to let you dig into the issue and then solve it again, and then resolve the problem. Sorry. And finally, this last slide, this is a lot of talking on this slide. So where do we focus our efforts? So once you have critical mass on your postmortems, you'll start to see these patterns emerge, and you'll be able to identify where you should shift your engineering focus. So looking at our production lifecycle, like I mentioned, what we really are trying to focus to do is reducing the time it takes for someone to detect, reducing the time it takes to mitigate, and then increasing the time between our failures. And the way to do this is we can look at some practices here. So for time to detect, monitoring, absolutely essential. You need monitoring to even just collect data and get observability into your system. SLIs and SLOs, we need this to focus our attention towards our customers, which are the main focus of our business, and make sure that the alerts we're getting are effective and they affect what matters to us. What matters to us which is the customers, right? And then alert delivery. If you are going on call, there needs to be a way for a page to notify you, whether it's making a really obnoxious sound on your phone or sending you 1,000 emails, right? You need some sort of alert delivery system that will awake you and get your attention to an issue. And then for time to mitigate, we look at on-call training. So, if you go to the doctor and you need to get your appendix removed, you wouldn't want to have a doctor who's never trained and done this, right? Like, you can say that for pretty much any profession. So why would it make any sense to have somebody go on call for $1 million or $1 billion service if they've never been trained to do so? And the way that we do this is various methods. We can do pair on calling, we can do shadow on calling, we can be involved in on-call training exercises like disaster recovery testing or wheel of misfortune exercises. And these are basically just simulations that you do with your teams to see how individuals will respond to a simulated disaster. And the next thing you want to look at are playbooks and runbooks. If you're going on call and you spend all this time just figuring out what the issue is, you see this document, you open it up, and it says, and everything is outdated to actually help you fix the problem. That's an issue there. So you need to make sure that the playbooks that you're using are updated and they're easy to follow and they're centrally located so people can find them quickly. And the thing with runbooks and playbooks is that usually you just follow it step by step, right? Somebody who's alerted to an issue is already really stressed, so they don't need to spend the amount of time to just understand the document itself. They just need to like run the steps they need to mitigate the problem. And generally, at the end of this, like if you have such routine processes like that, it makes sense as engineers to automate this, right? Like if you look at your runbooks, how many of those things can be automated so that you can focus your time and efforts on something else, so that humans don't make these mistakes when they follow your instructions, right? Because humans will make mistakes. That's a given. And the next part of reducing time to mitigate is reducing responder fatigue. I know it may seem really annoying when you have an issue that isn't taken at the highest severity, and that does happen a ton, but it's not realistic. Your on-callers can't be expected to respond to an issue within 5 minutes and then start working on it, right? They have lives, they have family that they have to attend to. Like even getting on the subway is something difficult. You can't respond to something within 5 minutes. So you want to make sure you can reduce your responder fatigue by setting the right expectations for on-call. What constitutes what level of severity, what level of priority, and then document that somewhere so that people who are opening these problems and issues up are able to read this and say, oh, okay, I just opened this up. I won't see a response for like a week or two, right? And that really reduces the operational load on your responders. And the next thing is to have dashboards. That's a given. Like you need to be able to see the state of your system at all times. And ideally, you're measuring some of the more important signals like availability and latency of your service. Same thing with logging. You need to have logging so that people can actually dig in and investigate the issue. And then we move on to helping to increase the time between failures. We look at things like developer practices and good engineering practices. If you don't already do so, does your organization do code reviews? Is there a way for somebody to have another person check their work and then send them approvals, right? Is there a check and balance system here? You want to have some sort of CI/CD pipeline. Is your build and integration and release process robust enough and automated enough that you can avoid sending a bad release or being able to even roll back releases? And the next thing is robust architectures. If your service has a single point of failure somewhere, can you go ahead and fix that so you have some sort of redundancy so that not your entire business isn't dependent on one small server you have somewhere in someone's closet or something, right? And the next thing is doing a bit of chaos engineering. This is something I've seen trend up in the recent years, is testing in production. Essentially what you do is you just submit a change in production that's breaking, and see, obviously, hopefully it's small enough, but you can see like it, but it is a breaking change that you can see how your production services react to it, and then you can fix and iterate upon the solution afterwards. And then the next thing is capacity planning, right? If you know if you're a big retail service and you know like Black Friday, Cyber Monday is a huge thing for your company, you need to make sure that you have the capacity to handle those increased traffic when that time comes. And it's not just that, right? If you know you're releasing a feature, you're expected to see peak traffic, you're expected to see a spike of users. You need to be able to plan and doing the capacity for that as well, right? These are all sorts of practices that you can use when you want to focus on reducing the impact to your customers when there's an incident and resume your business as quickly as possible. And then finally, the last slide here is just this is just basically everything I said, but in book form. if you are interested in reading about more of the practices and more of the principles of SRE, I recommend you look at these books here. The first two we have available online for free. And it's something that my
saying is when it comes to is SRE comparable to a PCF platform? So Alan was saying SRE is a process, group, and mindset practice that organizations implement to better work together more efficiently and effectively. And it's an extension of your DevOps or how Google implements DevOps. PCF will be comparable to our Cloud Run platform, serverless container technology built on Knative. So if you'd like to learn more about that, Alan actually pinged the link to Cloud Run for you to be able to check that out. So for our first question that we have for Cindy, someone would like to know, can you provide an example of calculating / establishing an error budget?
Yes, so let's say you have a service that users access about 100 times a day, right? And then if they access your service, they get an HTTP response or any like a successful 200 response back, right? If it's successful, and let's say in a given day you only get 90 successful responses. The other 10% were errors, like server 500 errors, right? And so you would say your reliability at this level is 90%. So you can take this 90% as your target, your SLO, and you do the inverse of this, which would be 10%, which is your error budget, which leaves you 10 unsuccessful requests to your site. So that's how you would calculate error budgets. But obviously you would do it on a magnitude of whatever number of requests and whatever number of interactions that you deem for your reliability of your service. Hopefully that makes sense. So like your error budget would be if you measured this and you got 15 unsuccessful requests, that means you have completely maxed out your error budget and you need to focus on reliability. That makes sense. Yep.
Thank you. And our next question is, how much automation does SRE provide even before manual intervention, like capturing common failure scenarios and trying to apply scripts?
So I mean, it really depends on the team, but in general, you want to provide as much automation as you can to reduce the amount of human error. So for some services at Google, when you even go through a release, as it goes through the release and it does a progressive rollout, it'll do a canary on a few machines and it sees an uptick in errors. So it just stops the rollout process automatically, rolls back to a stable version. So it really is going to depend on your service and your team, but in general, honestly, like the more automation, the better. Like you can catch these problems, and like I said, you can catch them by seeing these changes made in progressive rollouts with canaries and things like that.
Awesome. And then for one of the final questions on here is, if I want to include some open source or third-party plugins for some services, how well SRE is going to support, and how easy is it to implement it with SRE?
So there's a couple components to this question in that if you want to include third-party support, you are then kind of beholden to these services that you're dependent on, right? If I'm running services on some platform that I don't 100% control, you need to make sure that you build your reliability targets based on these dependencies. Like you're not going to build a website with 5 nines of reliability when your internet service provider can only give you 3 nines of reliability. So you need to think about these things when you're thinking about reliability of your service when you bring in dependencies. And the other component that I was thinking of is, I wasn't sure if that was also a question on security or is it just reliability in general, but somebody asked me something similar and I gave them a little thing on security, especially if you're doing like open source, but I don't think it was that. So I'm just going to leave it at the first part. Sorry.
Awesome. Thank you so much. So that's all the questions I see in the chat. Does anybody else have any questions they'd like to ask?
I have a question.
Go ahead.
Hi, my name is Colina. I'm an FSR out of Charlotte. I joined about a month ago. So my question in regards to just this whole topic is in comparison to the world that I just came from, which was data privacy and security. And we always say that security is a moving target. It's not a destination. And while a lot of stuff is reactive, and we had ML and AI tools to identify risk and to automate reporting and things like that, there was still a lot of proactive kind of measurement of things, constantly shifting. There were structured timelines in which things were established or reestablished. That was largely due to cybersecurity as a community, and everyone always talking about errors or talking about risks, right? So because of that, there was the ability to be proactive when a threat might happen to one. Right. So how is that comparable, if at all, to this? You talk a lot about postmortems. You talk a lot about debriefs, and these are very reactive. So is there a proactive quality to this other than establishing specific levels of reliability? Beyond that, is there any best practices surrounding the frequency in which one relooks at somebody's standard operating procedure, or is it mostly reactive? Thank you.
No.
Sorry. I don't. This is the first time I've actually really been able to dive deep into this, and it's very interesting. So I'm curious to learn more.
No, that was a great question. So I honestly would align SRE with security the most in terms of like how organizations see us, even just getting people to adopt these things, like you said, for reactive and proactive measures. And also, people look at us like, in general, people look at security and they look at privacy and they look at reliability as like obstacles to get their work done, right? They want to release as much as they can, but you have all these obstacles in place. So it is, we kind of struggle the same way there. To answer your question about preventive measures, though, we definitely do have stuff on preventive measures. So like when you go to that production lifecycle slide where I talk about increasing the time between failures, we look at making sure that when you're reviewing their architecture, that they don't have single points of failure, that they have like robust architectures. Maybe they have graceful degradation, so like a service doesn't go completely down. Maybe you just degrade the quality for a little bit for your users, but in general, the service remains up. So there is both a reactive and proactive aspect to SRE as well. I can give you more detailed examples and like point you to the specific chapters in the book. So if you want to,
that would be great. I'm definitely going to ask for the book. So I appreciate it. Thanks.
Yeah, no worries.
Awesome. And then we have one last question, and that is, how is SRE different from DevOps?
So like I mentioned in the previous slides, there is DevOps breaks down these silos between developers and operations, and obviously it has a huge success in the community as well, in the industry. And the thing with SRE is that we also add this additional domain for aligning with the business. So we balance our development velocity with reliability, but we also have these business targets that we agree with our product managers, like, hey, our product managers want us to reach this level of reliability, and then everyone kind of aligns on that perspective. So I think the difference is that we kind of try to tie into business goals as well as doing the with dev and operations.
Awesome. Thank you so much, Cindy. Jack, if you'd like to go to our next slide. So everybody, thank you so much for tuning in for this installment of OK Google Tell Me How. So as many of you know, this is a weekly webinar. So for next week, we're going to talk about VPN capacity and cloud-based VPN alternatives for publishing your internal apps, featuring one of our customer engineers out of the Southeast region. All of our webinars are on Thursdays, and they're always at 1 p.m. in case anyone needs a friendly reminder. So please tune in next Thursday, May 7th at 1 p.m. And then for those, Jack, if you, oh yeah, sorry about that. We'll be sending out a survey about this presentation. So please let us know your thoughts and what you'd like to see next. Like I said earlier, any topics that you guys have a strong interest in, we can add that to our webinar series. And then for the last slide, I just want to thank everybody for attending today. I know someone had a question on my email address again. So my email is at the bottom of the screen. You can reach out to me for the SRE book, as well as myself and Jack. If you have any questions around SRE or anything Google, we can help get your questions answered. But we'd love to continue the discussion. So don't be shy. Please reach out, and we'll see you next week on OK Google.